Okay, this is for Geometry Honors. We're going to take the notes in 12-4 on angle measurements and segment lengths. So obviously get your notes out 12-4. And let's hope this works here. This first picture here with the secant line is basically a line that hits the circle twice, unlike a tangent which hits it just once. So this right here in this picture is a secant line. And so we are going to be having crisscrossing secant lines in a circle. And this first box here, this first rectangle box, is about the angles. And so you got to pay attention. The angles that they're talking about inside the circle, or is it outside the circle? If it is inside the circle, like angle 1, if you look at angle 1 right now, it looks like it's only hitting arc X. But you got to remember, because of vertical angles, this is also angle 1. And so it does hit arc Y as well. And so both arc X and Y are used in this particular problem. It is going to be half the sum, of course that means adding, of arc X plus arc Y. All right? That is when it's inside the circle. This next one here is when they are outside. You'll notice angle 1 here is on the outside. In this picture here, there's angle 1 on the outside, angle 1. These are all different versions of when the angle's outside the circle. And when you are outside the circle, you intercept the arc in 2 spots. So like for this first one, it would hit it X here and then arc Y here. For this one, it would be arc X there in red and then this Y. And this guy, this is all of arc X, and I'll change the color here, and this would be arc Y. But in all 3 cases, it's all the same, and the formula, if you are outside, is 1/2 arc minus arc. And that is the main difference between when you're inside, you add, when you're outside, you subtract the 2 arcs. All right, let's move on to segment lengths. Now this guy is, again, kind of similar. This first circle here is when 2 segments inside are both inside the circle, and these 2 here are outside the circle. And there's basically 2 different formulas. I like to use colors when they're inside. It's basically just blue times blue is equal to red times red. And those are the segment lengths. This has nothing to do with angles. So blue times blue is equal to red times red. Portion of one secant chord is equal to the split portion of the other secant chord. When it is outside, now this is way more, this is a crazy looking formula right here and right here. But basically what's going on here is they're taking the whole line times the outside portion is equal to the whole line times the outside portion. And I'll just use different colors. But that's the same with picture 2 and 3 here. So you would take, I'll just use colors here, the whole line in blue times just the outside portion in blue. The whole line in red is equal to the outside, times the outside portion. So you take the whole line times the outside is equal to the whole line times the outside. And the same would be with this one. The only difference with this third picture here is the whole line here in blue times the outside portion, which is just segment Y. And then the whole line here is a tangent line, so it's both the whole line and the outside portion. But you would multiply those 2 reds, and that would equal the long blue times the short blue. Okay, let's see if we got one problem here. We're going to do problem number 2 here. And we have 2 secant lines intercepting the circle. It is hitting it on the outside, not inside, it's outside. So it's basically, to solve this, it's the whole line times the outside portion is equal to the whole line times the outside portion. And so this blue line here, the whole line is 20 plus 14. The outside portion is just 14. And that should equal the red line, the entire line. The whole line there is x plus 16 times the outside portion, which is just 16. And I'll be honest with you, I don't have a calculator in front of me. I don't know what this equals, but you would just do the distributive property and solve for x there. Okay, and that is all we're going to fill in for 12-4, but there's a lot of little formulas here. You can see inside or outside the circle, whether you're arcs and angles, inside or outside the circle, whether you are segment lengths. All of this is just more formulas, and eventually when we have a test or quiz, I will actually allow you guys to have little note cards or maybe even this cheat sheet itself, because there's just so many little formulas to memorize. And let me stop this thing.